So in this angular momentum problem, we have a force of 300 newtons acts on a 2.5 meter long rod initially at rest, shown in the picture below. Okay, what is the total torque acting on the rod? So I find the formula, torque equals force times radius. So you're going to do 300 newtons times 2.5 meters equals 750 newtons times meters. So that's the torque. B is what is the final angle momentum for the rod. If the force acts on it for 8 seconds. So we end up using torque equals change in linear momentum. Change in angular divided by change in time. So we want to get the angular momentum by itself. So you're going to do change in time times to cancel out, and you're going to move it to t delta t. Change in time equals angular final and angular initial. Well, initial you already know is going to be 0 because it says at rest. So we go ahead and just cancel that out, and it ends up being angular final equals torque times change in time. And you're going to plug it in as 750. That's what we got right here for the torque. Times 8 seconds, which they asked us for in the problem. Gives you final angular momentum is 6,000. And part C wants us to find what is the final angular speed for the rod. Well, this is 2 parts. You can't just automatically go to finding the speed. So first you need to find the inertia. And to find the inertia problem, the formula is inertia equals 1/3 mass times length squared. And you're going to take 1/3 divided by 10 times 2.5 squared, because we're going to use the entire length of this platform. And that gives you 20.83 inertia work force. So now we got to figure out the workforce to get the speed. So we're just going to plug in final angular, which is 6,000 that we got right here, divided by inertia, which is 20.83, which gives us a workforce of 288 radians per second.